this integral involves root x squared plus 1, which is same as root 1 plus x squared. Let me write in that way. Root 1 plus x squared on the top over x. And this is one of those three standard forms. In this case, we have root number is squared plus some function of x squared. In this particular question, a is 1 and u is simply x. And we know whenever we have a squared plus u squared, then we make the substitution u equals a tangent theta. Okay, now we do the same thing here. Let u be, okay, u means x in our case, so x equals a is 1 tangent theta, so x equals tangent theta, and we want to convert this integral in terms of theta. Okay, so we want to find dx over d theta. Derivative of tangent is secant squared theta. Okay, with this substitution we get integral of, on the top, 1 plus x squared. X is tangent theta, so tangent theta is squared, so tangent square theta over x. X is tangent theta times dx, and dx is, we just found, secant square theta d theta. Let's simplify this. 1 plus tangent square is secant square, and root secant square is just secant. Okay, that was the purpose of substitution. X equals tangent theta, then we can get rid of this square root. Yeah, we have now without square root, secant theta over tangent theta times secant square theta d theta. Okay, we are more comfortable working with sine and cosine, so let's change everything in terms of sine and cosine, because secant is reciprocal of cosine, 1 over cosine. This is also 1 over cosine squared, and tangent is sine over cosine. At the same time, secant times secant, secant cube on the top. Secant is 1 over cosine, so 3 of them, so cosine cube theta. Okay, cosine cube theta divided by this division. Tangent is sine over cosine, and cosine goes on the top, cosine over sine. I change this division into multiplication, so sine over cosine on the bottom flips and becomes cosine over sine d theta. Let's see, we have one cancellation, at least cosine and one cosine, 2 of them left, so we'll have now 1 over cosine is squared and 1 over sine. Okay, so 1 over cosine means secant, so we have like secant square here, and 1 over sine is cosecant theta d theta. Now we got a product of two functions, and now we have, I can see at least 2 methods. Let me show you both. I can see as a product, so integration by parts, so I'm going to write cosecant in the first place and secant square theta d theta in the second place, because I know the derivative of, antiderivative of secant square. Antiderivative of secant square is tangent. So integration by parts, IBP, integration by parts, u is cosecant theta and dv is secant square theta d theta. I know how to take the antiderivative of secant square, so I chose secant square to be dv. So v equals antiderivative of secant square is just tangent. Here the derivative of cosecant is negative cosecant cotangent. Okay, this integration is not easy, it involves some work. Then integration by parts, uv, always uv minus v du. That means cosecant theta tangent theta minus antiderivative of v du. So du is a derivative of cosecant, was cosecant cotangent times d theta. I forgot to write there. So v du. So I was mentioning when we have u dv, the integration by parts, uv minus v du. Okay, so v times du is a negative, that makes this formula negative to positive. Tangent theta cosecant theta cotangent theta d theta. D theta is hidden here. Okay, now when we are done with this part, we need to do this part. We can simplify because cosecant is 1 over sine and tangent is sine over cosine. So let me simplify. 1 over sine times tangent is sine over cosine. Then I have a cancellation. Plus, let's do the same thing. Let's try to simplify again. Write down everything in terms of sine and cosine. Tangent and cotangent. By the way, cotangent is reciprocal of tangent. So tangent times, we can write cotangent as 1 over tangent. In any case, tangent times cotangent is 1. You can write tangent is 1 over cotangent, and cotangent to cotangent cancel. Or you can go for sine over cosine, cosine over sine, they cancel. In any case, we are left with cosecant theta d theta, and the left 1 over cosine, which is secant, plus now the antiderivative of cosecant. Thus you may have memorized the formula. Okay, use substitution, and antiderivative of cosecant will be natural log of cosecant minus cotangent theta plus c. Okay, you can look at this integral in the substitution, the method of substitution section. We are not done, okay, because the original question was given in terms of x. Okay, x equals tangent theta was our substitution. So we are going to use x equals tangent theta, this substitution, to convert this answer in terms of x. So tangent theta is x means x over 1. So let's draw a right triangle with angle theta. So tangent is always perpendicular over base, okay, height over base. So x over 1, a square plus b square equals c square. Then we can find c, and this is x a square plus b square equals c square. So c is in fact root x square plus 1 or 1 plus x square, doesn't matter. Okay, then secant, that's the reciprocal of cosine. Cosine is 1 over c. Okay, secant is now c over 1. So c over 1 means root 1 plus x square, plus natural log of cosecant is reciprocal of sine. Sine is in this right triangle x over c. So cosecant is c over x. C is root 1 plus x square over x minus cotangent. Cotangent is reciprocal of tangent. Okay, tangent is x over 1. So cotangent is 1 over x. So 1 over x plus c. Okay, this is finally, you can combine these two terms. So let me go that 1 plus x square plus natural log of absolute value 1 plus x square minus 1 over x plus c. Okay, now this is the final. As I told you, the integration of cosecant times secant square, this can be done without using integration by parts. Okay, let me do over here cosecant times secant square, but that involves a lot of trigonometry. Let me do anyways. Cosecant times secant square. Okay, integration of cosecant times integral of cosecant times secant square d theta. we can write secant square as 1 plus tangent square. So cosecant theta 1 plus tangent square theta d theta. Let's distribute cosecant. Then we have cosecant theta integral plus integral of cosecant times tangent square. Cosecant tangent square, that equals, in any case we have to use formula. Integral of cosecant is natural log of cosecant minus cotangent plus for cosecant times tangent square. Let's try to simplify. Cosecant is 1 over sine and tangent square is sine square over cosine square. Okay, now I can see cancellation. So cosecant theta minus cotangent theta plus sine, 1 sine cancel. So we have sine over cosine square. Okay, sine over cosine square. And by the way, sine over cosine square can be written as sine over cosine and 1 over cosine. Okay, natural log of cosecant theta minus cotangent theta plus 1 over cosine is secant, sine over cosine is tangent. Now integral of secant, I'm writing this second factor first, times tangent. Now this is well known, secant times tangent is derivative of secant. So this is natural log of cosecant minus cotangent plus antiderivative of secant tangent is just secant plus c, which is what we got earlier. Okay, secant plus natural log of cosecant minus cotangent plus c. Okay, that's an alternative way. If you are wondering how we found the antiderivative of cosecant theta, okay, that is just a basic u substitution, but you need to do something before you make that. So you want to multiply cosecant by cosecant minus cotangent. Multiply the top, multiply the bottom. Cosecant minus cotangent. Okay, now this top, if we multiply cosecant minus cotangent. Okay, let me write down this first. Cosecant times minus cotangent is negative cosecant cotangent, and plus this one to the first is cosecant square theta, and on the bottom we have cosecant theta minus cotangent theta d theta. The magic here is the top is just the derivative of bottom. Okay, what is the derivative of cosecant? Negative cosecant cotangent minus what is the derivative of cotangent? Negative cosecant square minus and negative plus cosecant square. So the top is, in fact, now we have this form. The top is 1, the derivative of u is 1 with respect to u, so du over u in this form. The top is the derivative of bottom, then the integration is natural log of u, absolute u. So we have the exact situation. The top with d theta is the derivative of bottom, so the entire derivative is natural log of absolute value of bottom, cosecant theta minus cotangent theta. Okay, plus c is always there. That's what we used earlier.